The section's on 3.8 inverse trig functions. So we've learned how to do the derivatives using the 7 rules of the differentiables, and then we also did is we added onto it the trig functions, and then on top of that we did the chain, which we spent a couple of days on, and now what we're going to add onto that is the arc inverse trig functions, okay? So let me go over those. So that if you remember, we're going to take the derivative of the arc sine. So we did these arc functions in pre-calculus, but we actually find the angles of this, and now in calculus we're going to take the derivative of them. So the derivative of arc sine is 1 over 1 square root of 1 minus x squared times the derivative of x, which means I'm taking the derivative of this. So this is actually similar to the chain rule. What happens is we're taking the derivative of this piece right here, which requires a formula right there, and then we're going to take the derivative of the inside, which is this piece right there. That's like the chain part of it, okay? So we also have is the arc cosine. So arc cosine, we're going to take the derivative, which becomes this right here, -1 all over the square root of 1 minus x squared. Still the derivative of x right there, so that doesn't change. The arctangent, same thing. We have is 1 over 1 plus x squared times the derivative of x right there. Derivative of our cosecant is going to be -1 all over the absolute value, so this is a little different, so pay attention to that one. Times the square root of 1 minus x squared times the derivative of x still. The arcsecant is going to be 1 over the absolute value of x right there times the square root of 1 minus x squared times the derivative of x. And then the arc cotangent is going to be -1 divided by 1 plus x squared times the derivative of x. So if you look at it carefully, similar to what we talked about on the derivatives for the trig functions, all the c's have negatives. So for example, the cosine right there is exactly the same as the sine right there, except this has a negative right there. The other one is then cosecant, exactly the same as the secant right there, as you notice, right? Except this is a negative right there. And then same thing, the cotangent and the tangent are exactly the same formula, except for the cotangent has a negative. So technically you have these 3 other formulas that you need to memorize, okay? So let's go ahead and try this now. So example number 1 says take the arc cosine right there, and then the x part of it is going to be 5x cubed divided by 3. So let me just put up the formula right there. So all of this right here is your x. So we're going to substitute into this x part right there. And then we're also going to take the derivative of x right there. That's the chain part of it. So we're going to take the derivative of that and multiply to the chain part of that. Okay? So let's go ahead and do that. So we're going to substitute this into the x, and take the derivative. That leaves me something like this. So the derivative of 5x cubed divided by 3, we bring the 3 down, right? We subtract 1 on the exponent, the 2 on the exponent, the 3's will cancel out, leaving you at 5 right there, so that gives us 5x squared. And then on this part right there, I left it inside that x right there, and we're going to have to simplify all of this right here. So when we square this, this is going to be like 25 over 9, right? Because we square that, and this is going to be x to the 6. So let's go ahead and simplify that. I brought this also up right there because this 5x squared is the same thing as saying 5x squared over 1. So I'm going to multiply the tops together, try to make it as much as possible, simplify it for him. Okay? Now here, I also have a fraction introduced, so that means we have to find common denominator. So the common denominator is obviously 9, so we're going to have to make this as a 9 over 9. So when we put that together, it's going to look something like this. 9 minus 25, x to the 6th power, all divided by 9. Now, in some cases, you may actually split up the square root. We're going to take the square root of the numerator part of this, or the top part of this, and then the square root on the bottom part of it. The reason I want to do this is because square root of 9 is actually a perfect number, so which is going to give us something like this, a 3. Okay? Now, technically, this right here is a fraction. It's -5x squared over 1, right? And this is also a fraction right here. So we learned in Algebra 2, we don't like fraction divided by a fraction. We need to simplify this. So we're going to multiply by the reciprocal of this. So the 3 is going to come up right here and basically multiply by the 5, giving us -15x squared. And then the denominator becomes the square root of 9 minus 25x to the 6th. This is probably the most simplified form you can do. You cannot take out the 9, nor can you take out the 25. Why? Well, that's because there's a minus in between it, right? If it was a multiplication part right there, then you could probably bring things out of that square root right there. But because there's a minus or plus, then you cannot separate that, okay? Alright, let's try example number 2. So example number 2 is an arctangent. Now I spelled out the word arctangent, if you remember from pre-calculus last year. This is the same thing as the little tangent with the -1 as well. They're both called arctangent. So either way, I want to make sure we introduce both ways of the format for the arcs. So that way on the AP test, if it shows up this way, you know how to use the formula, and then vice versa as well with the -1 exponent. So let's put up the tangent, arctangent formula. So arctangent is 1 over 1 plus x squared times the derivative of x. So all of this right here becomes the x right there. We're going to substitute into that spot right there, and also take the derivative of this piece right here. So this is what it looks like right there. Okay, so this is again 3 over 1, so I'm going to bring the 3 up here. Now normally on the denominator we want to keep it nice and tight, but because we have actually a number, or if you have a variable as well, you actually want to distribute this out right here and then combine like terms right there. So if I distribute this right here, we're going to get something like 9x squared plus 6x plus 1. So the 1's right here will combine like terms, and that gives me a 2 instead. Okay, so that's your final form right there as far as the derivative of the arctangent of 3x plus 1. Alright, let's try another example. Example number 3. So this is now arc cosecant of -x squared. So the formula is -1 divided by the absolute value of x, right? Times the square root of 1 minus x squared times the derivative of x. So let's go ahead and again put this, all of this into the x's. Now there are 2 spots. We're going to put it inside the absolute. We're also going to put it inside the square root as well. So we have something like this right here. Okay? And don't forget to take the derivative of that. That's where we got this -2x. Okay, we're going to bring this 2x up here. That gives us a positive 2x right there. We're going to simplify right here. So anything squared is obviously positive, so that's going to disappear. X to the 4th is what we have right here. So this is what it looks like right there. Okay, now we can't, again, bring anything outside of the square root. I can't simplify it any further, so I'm going to leave the square root right here. But this is an absolute value times the square root. And again, the rule is if it's multiplication, we can always simplify and cancel numbers or variables out. So we have an x up here, which is 2 times x, and we have this right here times this. So we actually can cancel out one of the x's, even though it's in the absolute value. We can cancel out one of the x's right there and leave whatever is remaining inside. So this is what it looks like as far as the final answer goes. Okay? So you can actually do that. So if you have a problem or come across to a problem like that, you can actually cancel out an x. Alright, let's try another example. Example number 4. Now notice this is actually a UV right here. So that application of that UV multiplication and also UV quotient still applies. We're still going to do UV, but when the process comes along and we use the derivative of either a trig function or derivative using the chain process, any of that stuff, that's what we're doing. So in this case, we're going to take the derivative of the arc cotangent. So let me put the formula for the arc cotangent up. It's -1 over 1 plus x squared times the derivative of x. Okay, so since I'm doing my UV, I'm copying my u, right? Take the derivative of v. This derivative v requires using this formula right here. So I'm going to substitute all of this right here into my x right there, right? And take the derivative of x. Then I go plus, because it's multiplication, we go vu. So all of this is your v. We copy the v, take the derivative of u, which is 1. So this is what it looks like, something like this. Okay? Now, I'm going to simplify this. I'm going to bring the 3 up on the top and also the x, because this is like x over 1, right, times all of this, times the 3 over 1. So I can bring all of those up there. This right here is the same thing as the previous example. We're going to probably distribute that, combine like terms right there. In this case right here, I cannot simplify that any further, so we're actually going to leave that as it is. So let's continue on. I bring the 3 up, the x up right there. Let's go ahead and distribute this out right here. So it gives us something like a 9x squared minus 12x plus 4. And then we're going to combine like terms right there, giving us that 5 right there. And again, we can't touch this part right here, so leave it as it is right here. So this is the most simplified form you can have. And no, I know it kind of looks ugly for some of you because you're not used to seeing all of this fraction and all this arc cotangent and things like that. But it is what it is, so we'll just leave it as it is, okay? Alright, so now let's go ahead and try the classwork problems for these.